So now we've already mentioned this a few times before, but let's explore the idea of other things that are conserved during a collision. To talk about this, I want to more carefully define our bouncing and sticking collisions, or elastic and inelastic collisions, which are not exactly the same thing, right? So there's a bouncing collision, which says that before and after the collision, the two bodies, if two objects, and we'll just stick with two objects, if object 1 and object 2, whoops, I wrote a C for some reason, object 2, if they have initial velocities of v1 and v2, and after a collision, they've got different velocities, we'll call it v1 prime and v2 prime. Whoops. In the habit of using primes, but generally we use unprimed variables in this situation as being before collision and primed as after, so sort of initial and final, slightly easier to write. So in a bouncing collision, the two objects bounce off of each other, and they have different velocities before and different velocities after. Versus a sticking collision, regardless of what two objects they are, if they collide, I guess right, this is meant to be where they collide, then after the collision, they are stuck together and they go off with the same velocity, so we can take away the subscript, v prime, v final. So that's a sticking collision. In a sticking collision, the two objects have the same final velocity. In other words, v final, 1 equals v final 2. Okay, so that, first of all, it's important to just understand those two. But then we've got what's called, we can go further and characterize these as elastic and inelastic collisions, but we've got to be careful. So we've got inelastic collisions. So we've got to be careful about the definition of inelastic and elastic collisions. Because it's different sources may define them slightly differently. But inelastic collision really means that energy is not conserved during the collision. Kinetic energy, we're generally talking about, because the potential energy is not changing during the collision, but energy is not conserved in the collision. So we generally mean kinetic energy, because think about it, in a collision, the potential energy is not going to change because we're just talking about it instantaneously. It's not going up or down. We're just talking about what happens right before the collision, right after the collision. So kinetic energy is not conserved in the collision. In an elastic collision, kinetic energy is conserved. Kinetic energy is conserved in the collision. No energy is lost to heat, right? In an inelastic collision, the kinetic energy, where does it go? It's lost in heat that's generated in the collision. In an elastic collision, kinetic energy is conserved, so no energy is lost in heat. So the first thing you probably should realize is that there's rarely such a thing as a perfectly elastic collision, because in every collision you generate a little bit of friction, you generate a little bit of heat. But in an ideal situation, or in it's just about elastic, right? We do idealize a lot of situations in this class. So we can talk about a super ball, a really, really bouncy ball that gets back all the energy that it gives away when it hits something. And we say that it's mostly elastic, or we can treat it like it's an elastic collision when a super ball bounces off a floor. But okay, so what do the inelastic and elastic collisions have to do with bouncing and sticking? Well, always, a sticking collision is always inelastic. A sticking collision is always inelastic. You always lose energy in a sticking collision. A bouncing collision is not necessarily elastic, but an elastic collision is necessarily a bouncing collision. So a sticking collision is always inelastic. An elastic collision is always a bouncing collision, because a sticking collision is always inelastic. But bouncing collisions are not necessarily elastic. So, written it out here. Sticking collision is always inelastic, therefore an inelastic, therefore an elastic collision must be a bouncing collision. But that doesn't mean all bouncing collisions are elastic, because you can still lose energy in a bouncing collision. So what you'll see sometimes is that inelastic collisions are really defined as sticking collisions, and elastic collisions are defined as bouncing collisions in which the kinetic energy is conserved. And then there are partially elastic collisions, which are bouncing collisions in which energy is not conserved. But the differences come in, does an inelastic collision necessarily need to be a sticking collision? If in a bouncing collision you don't conserve energy, then isn't that an inelastic collision? It depends on whether you want to use the words partially elastic or partially inelastic or not. But those are complications I wouldn't say worry about. I'd say do not worry about. An inelastic collision, we lose kinetic energy. An elastic collision, kinetic energy is conserved. Bouncing collisions are the only kinds of collisions that can be elastic, but they're not necessarily elastic.